Assalamualaikum, good morning. So this is the last chapter for this course, chapter 6 for lipids. So this chapter actually is quite short, okay, so you can finish in one or two parts of lectures. Okay, lipids are a compound that can be extracted from cell by non-polar organic solvent. Okay, so by this information, we know first is a lipid is an organic solvent, organic compound. That's why it can be extracted by organic solvent. And second is a non-polar compound. It's a non-polar, means it contains a lot of carbon and only one or just a few of other atoms. And then we can classify lipids first to complex lipids. Mean the lipid we can hydrolyze. Okay, we can hydrolyze. We can break the lipids. For example, it contains a long chain ester we call fatty acids. Okay, or for example like fats or glycerides. Second is a simple lipids are not easily hydrolyzed in acid or base. Okay, I mean this kind of compound or lipids, they are quite stable and usually very hard to break because it's already in the simple or in the base forms. It is example of complex and simple lipids. For example, for complex lipids, fat, or we call is one of the fatty acids, tristerines. Okay, and then it's a wet. For simple lipids, for example, like steroid, cholesterol, one of steroid. Okay, and then terpene. Okay, first we look at what is a fatty acids. Okay, fatty acid actually is a carboxylic acid compound that contain carboxyl group, carboxylic acid with 12 to 20 carbons. It's an unbranched. Most contain an even number of carbon because they are built from acetic acid unit. Okay, so in nature, fatty acids, the building blocks are acetic acid. Okay, melting point increase with increasing molecular weight is normal. Unsaturation greatly lowers the melting points. Okay, for example, if fatty acid A contain 20 carbon, acid B also 20 carbon, but with 2 double bond. So in terms of melting point or boiling point, the one that have more double bond usually have lower melting points. Okay, so this table show melting point for fatty acid. Okay, this is a name, number of carbon, and then this is structure and melting point. So for example, the simplest one is a lauric acid. It's a 12 carbon. So 12 carbon. So this is the structure, contain only carboxylic acid and carbon, and this one saturated carbon. Okay. Okay, and then muriatic acid, 14 carbon in melting point higher than lauric acid. Yeah, this logic based on the van der Waals forces. Okay, and then if you look at the same number of carbon, for example, this is oleic acid. Okay, oleic acid contain one double bond. Okay, melting point is 4. Linoleic acid also 18 carbon, but contain 2 double bond and melting point drops or decrease. It's a -5 Celsius. Okay, and then we look glycerides. Glycerides is a fatty acid ester. I mean, from the fatty acid, this fatty acid, we react with alcohol to form ester, and that's what we call triglyceride. Okay, is a triacylglycerol, fatty acid of the triacylglycerol. Okay, glycerides are the most common glycerides, and they are used for long-term energy storage in plants and animals. Okay, so these are fats and oils. Triol, in this case, it refers to this alcohol. The mean is content of 3 hydroxy groups. Okay, so this alcohol will react with fatty acid. Okay, fatty acid react with this alcohol to form glycerides. Okay, for example, like this one. Draw tristearine or stearine which synthesized from reaction of glycerol and 3 fatty acid 18-0. 18-0 show or indicate the fatty acid has 18 carbon and no double bond, non-double bond. Okay, so this is the answer. Okay, the reaction actually from a fatty acid and with the glycerol with this one. So 1, 2, 3. Okay, so glycerol react with the fatty acid, 3 fatty acids to form the tristearine. Okay, tristearine. In this case, it's the same fatty acid. That's why it's the same for the top, middle, and bottom. It's the same. Okay. So if we change the equation, okay, let's say in this one, an optically active fat, when completely hydrolyzed, yield twice as much of fatty acid A, 18-0, as fatty acid B, 18-2. Okay, draw the structure of the fat. Okay, to solve the problem, it's the same with the previous slide. Okay, but for this one, the fatty acid has a two fatty acid of A and 1 fatty acid of B. Okay, and another hint is this one is optically active. Optically active means the combination. Okay, if I draw in a simple, mean this fatty acid A. Okay, react with the glycerol. So the combination will be AAB. Okay, so this combination is optically active because it doesn't have a plane of symmetry. Okay, if we arrange the fatty acid A, B, A, okay, A, B, A, okay, this one it contains a plane of symmetry. Okay, for this fat, it's optically inactive. Okay, this one optically inactive. Okay, this one optically active. Okay, so you can arrange AAB or maybe BAA. Okay, and then you must draw like this. Okay, either you want to use this a full structure or you can use like a condensed structure. Okay, condensed structure. Okay, but in a complete complete structure. Okay. Next, we look the melting point. For the cis double bond in oleic acid, lower the melting points. Okay, because it contains of a double bond. Double bond bend the molecule so it cannot pack efficiently. So basically, this information, okay, is about the surface area. So if content of double bond, mean the surface area will be smaller. Okay, so less van der Waals forces. Okay, that's why lower melting point. Okay, for trans double bond has less effect. Okay, so again, it's depend on the surface area. Okay, unsaturated triglyceride have lower melting point because the unsaturated fatty acid don't pack as in the solid lattice. Okay, it's about the surface area. Okay, next we look at the reaction. We have a fat, then we react with the base, for example, like sodium hydroxide in water, then we reflux. Okay, so it will break or hydrolyze uh, to form a glycerol and also sodium stearate, or we call soap. Okay, so in this case, it's based on catalyzed hydrolysis of ester linkage in fat and oils. Long chain carboxylic salts are known as a soap. Okay, so mean in this reaction, it will break at this position. Okay, this one also hydrolysis, but catalyzed by acid. Okay, but catalyzed by acid. Also, it will break at these positions, 1, 2, 3, to form glycerol and fatty acid. This is 3 fatty acids. Okay, so I will stop here. Thank you.